Ladies and gentlemen, welcome to the first in a series of webinars focused on energy optimization of compressed air. Well, it's great to have you here, and it's an exciting hour that stands before us. We are running this live and we are sitting in 4 different places in the world, so I hope we can deliver a smooth transition between the speakers, but you never know. The ambition with these webinars is to build awareness on the energy savings available in compressed air systems, but also to educate and to share experience on how to do that. There is a growing community of people in love with compressed air, and we are here to share some of that passion. There is more focus on energy optimization today, and of course the increased focus on sustainability topics and the pressure from initiatives like the Paris Agreement and United Nations Agenda 2030 is having an impact. The time is now. There has never been a better time to address energy optimization of compressed air. Behind these webinars, you find our company, Enersize. Enersize is on a mission. We want to be part of making the world a better place, and we do that on our side by developing tools and solutions for energy optimization of compressed air. We aim at becoming the global leader in compressed air efficiency software, and we do this by working very close to our customers, our partners, and the world's leading minds in this space. The Insight webinars are part of completing this mission. So let's look at today's agenda. After the introduction, I will hand over to our CEO, Anders Sjögren, who will share some surprising facts and also explain why we and our friends are in love with compressed air. It's a fascinating topic. We will then meet one of the world's most experienced experts on compressed air, our technical director, Mr. Bo Kuro. Bo has worked with compressed air in over 40 countries and been representing both the United Nations as well as the World Bank. He will give us a deeper insight into the magic world of compressed air. We will also meet our team lead from research and development, Rebecca Rubio Lopez, as we look at the roadmap and where we are investing from a product development perspective. Finally, we will also be sharing some of the upcoming activities and initiatives before we end today's session. But now, it is with great pleasure I will hand over to Anders Sjögren. Anders, please take the stage.
Great intro, Anders. Hi, my name is Anders Sjögren and I'm the CEO of Enersize. When I got started with Enersize 4 years ago, I had only the vaguest notion about what compressed air is used for in industry. I was thinking compressed air was something from yesterday and would be replaced by other technologies. But I quickly realized I was wrong, and now I can say that I'm in love with compressed air. And that is why I will take some time in our series of webinars to tell you about the wonderful and really cool world of compressed air. So please sit back, enjoy 10 minutes, and let me present current and historic use of compressed air. My first close-up experience with a compressed air system was when our old Saab got a rust spot on one door. My crafty father-in-law happens to be an expert car mechanic, and in his garage he had a large compressor with a buffer tank that originated from a cement factory. The compressor looks dangerous and is driven by a powerful 3-phase motor that makes a terrible noise. I was amazed. Why use such large and noisy machine for sandblasting and painting? Running the compressor uses a lot of electrical energy. However, and this is one of the reasons why we see so many applications of compressed air enables using small and light tools with high precision and power. Before I share some insights into how compressed air can be used, I want to bring you down to the tiniest details, the air molecules. Air in the Earth's atmosphere is a mixture of different gas molecules. I'm sure you've heard that. Mostly nitrogen molecules, but 1/5 is actually oxygen. The molecules move around really fast, and they have an average speed of roughly 300 meters per second, about the speed of sound. But they bump into each other all the time. Let's see what happens when air is compressed. I will use a great online tool by the University of Colorado Boulder. You'll find the link to the tool at the end of this presentation. We start with a container of air. You can imagine the red spheres to be nitrogen molecules and the blue ones oxygen. Now, if I compress the air by making the container smaller, let's see what happens. You see that the molecules bounce more often, and this means that the pressure is rising. And you can see that on the pressure gauge at the top right, which measures pressure in units of atmospheres. We see right now that the pressure is around 171 times the atmospheric pressure. If I open the lid now, the molecules eagerly leak out to the surrounding atmosphere. It is this action, the force of the molecules leaving the container, that we use in various applications of compressed air. The force of air is often used to scare people. Do you remember Arnold Schwarzenegger's popping eyes in the movie Total Recall from 1990 when he was exposed to vacuum in space? Vacuum means that there is no air. So the air pressure is too low for the human body. But of course, even if pictures like this give us nightmares, they are not even close to describing what actually happens. However, compressed air can really kill you. The oldest mechanical compressed air gun is from the 16th century and can be seen at the museum Livrustkammaren in Stockholm here in Sweden. The gun easily was the most dangerous gun at that time, shooting darts at a speed of over 100 meters per second. It utilized a bellows mechanism that you can see in the picture here that allowed for very precise action. So you see, compressed air can be wild, really dangerous, but contained, it can be very strong and useful. And that is why 10% of the electricity consumed by the industry today is used to generate compressed air. Components that operate on compressed air, they are called pneumatics. And pneumatic cylinders, they are the muscles of the manufacturing industry. And devices like these can easily lift more than 100 kilograms. Pneumatics can be combined to very complex instrumentation in all kinds of industry. However, compressed air can also be soft and caring, as in the form of breathing air supplied to people that are seriously ill. Compressed air is saving lives on a daily basis. As you will hear from Bo later, our technical director, the process of generating compressed air, however, is incredibly ineffective. So let's look at an industrial compressor. They can take many different shapes, but their basic operation is the same. They take atmospheric air and compress it into pipes that deliver air to the pneumatic machines in the factory. I said compressing air is inefficient, and the reason is that no matter how we try, we can't compress air without raising the temperature of it. In fact, as much as 85 to 90% of the electrical energy to a compressor is lost through heat. The mechanical energy of the compressed air is only a few percent of the electrical energy that we put into the compressor. Now, if you don't believe me, have you ever tried to use a cycle pump? Have you felt that it becomes hot when you pump? That is the effect I'm talking about. Compressing air for industrial use can cause it to become several hundred degrees centigrade. And therefore, in industrial compressors, they often have a built-in air cooling to remove some of the heat. But even if the compressed air is cooled inside the compressor, you can usually feel that pipes with compressed air are warm. Now, what if I have compressed air stored and I open a valve to let it out? Have you ever tried to use a can of compressed air? The temperature at the valve will quickly drop and can become as low as minus 150 degrees centigrade if you expand a lot of air. So compressing air increases the temperature, expanding air reduces the temperature. And this is the reason why generating compressed air uses so much electrical energy. But still, the benefits of using compressed air wins in many applications. We have learned that generating compressed air uses a lot of energy, and most of the energy is lost as heat. So using fossil fuel to generate electricity that in turn generates compressed air is one of the reasons why our global industry has such a large carbon footprint. Now, I want to bring you back in time to look at some usage of compressed air that will blow your mind. Given our society's aim to become more sustainable, I think it's just a matter of time until we see some of these applications revisiting us. Compressed air in itself is sustainable, clean, and powerful. The Chambers Encyclopedia from 1896 talks about pneumatic dispatch. What on earth is that? Well, you see these systems in operations today as well, often in hospitals, where they need to send blood and tissue samples with great speed. You simply put what you want to send in a capsule that is inserted into a pipe, and the capsule is pushed by means of compressed air. Now, can you imagine that back in the 1850s already, Mr. Latimer Clark and Mr. Varley built a system to dispatch messages between the central station and the stock exchange in London? The air was compressed using steam machines, and in 1887, there was compressed air pipes with an aggregated length of 54 kilometers and compressors with a total power of 280 kilowatts used to send a staggering 86,000 dispatches per day. In London, even large vessels like these that weighed several tons were sent by means of compressed air. And you might think that some ideas today are brand new, such as this Hyperloop, but in fact, already in 1865 in London, they built a 7-meter tunnel to propel carriage by the means of compressed air. And in France, a few years later, a compressed air-driven tram was inaugurated, and it operated for 30 years. They were using up to 94 trams at one time. In Switzerland, by the end of the 19th century, the city of Bern had 10 cars running on a 3-kilometer line, and the compressed air was generated by a compressor driven by water. I call that sustainable and something to think about. Compressed air has a lot more surprises to offer, but I will stop here today and hand over to Energize compressed air guru and technical director Bo Kuro. Thanks a lot for your interest.
Well, thank you so much for a very interesting session, Anders. I had absolutely no clue that compressed air had been used for so many years in so many different ways. I must say I can't wait to hear your future sessions as we are drilling deeper into the history and the use of compressed air in the upcoming Insight webinars. But now I have the joy of introducing another true thought leader and expert on compressed air, our technical director, Mr. Bo Kuro, who just came back from training our partner in Morocco. Hi, Bo.
Hi, Anders.
Please take over the screen. As I understand, you will be giving us a deeper introduction to the magic world of compressed air. So now the stage is yours.
Thank you, Anders. With pleasure. The next presentation, I would like to talk about facts regarding compressed air including CO2 emissions from generating compressed air, and the reason why compressed air is so expensive. The carbon emissions per kilowatt hour of electricity vary from country to country. They depend on the specific fuels used to produce the energy. Countries that use a high percentage of fossil fuels for electricity production will, in general, have a higher level of carbon emissions per unit of electricity produced than those that use more renewable and nuclear energy. But no matter how the power is produced, it is rooted in high voltage power lines and substations to the companies that use the power more or less sensibly, including for the production of compressed air. This is where Enersize comes into the picture. We can often reduce electricity consumption for compressed air production, thus the costs of electricity and maintenance, and ultimately the CO2 footprint. But let's get some facts on the table. There is a big difference between the countries in the European Union in relation to CO2 emissions, where Iceland and Sweden are at the better end, using geothermal, wind, hydro and nuclear power, but where in the countries with much greater use of fossil fuels have to deal with emissions in the order of 750 grams CO2 per kilowatt hour, and these data are from 2020. If you look at Asia, for example, China and India, it appears that in 2020 these two nations were at 555 and 708 grams of CO2 per kilowatt hour, respectively. In the European Union, CO2 emissions have certainly been declining in recent years, and the plan is to reduce emissions further, but it takes time. Enersize has solutions that can reduce the CO2 emissions here and now, and even with relatively short payback times, often less than a year. Most companies, no matter what they produce, use compressed air to a greater or lesser degree. Most compressors are driven by electrical motors, and in general, the most expensive source of energy per unit in many companies. But of course, it has not much to do with CO2 emissions. It has to do with the fact that most of the energy supplied to the compressor turns into heat before we have energy available in the form of compressed air. In fact, if you consume energy equivalent to 7.5 horsepower, you have 6.6 horsepower available on the compressor element shaft, but you only have about 1 horsepower available in the form of compressed air. The rest of it is heat, which, by the way, can be recovered. But what does compressed air actually cost in terms of energy? Imagine, for example, that we are dealing with 3 compressors from Atlas Copco in the size of 160 kilowatt, where 2 are fixed-speed oil-injected compressors and 1 oil-injected with VSD, variable speed drive. This is the technical specifications from Atlas Copco. Allow me to correct a small printing error in the material. It must be kilowatt, not horsepower. As can be seen, this compressor is available in 3 pressure variants: 7.5, 8.5, and 10 bar. Let's take a closer look at the 160 kilowatt 10 bar compressor. According to the specs, it can deliver 460 liter per second, corresponding to 27.6 meter cube per minute. But does it only use 160 kilowatt on this? Unfortunately not. This is the nominal power. The reality is that it uses some more power, in fact 178.6 kilowatt, as shown by these test data. But let's take a closer look at these data at, for example, 9.5 bar and pressure test them in our Enersize calculation tool. This calculation tool uses general thermodynamic rules and thus calculates a so-called isentropic power. I start with ISO 1217, where the reference is 20 degrees Celsius and 101,325 Pascal. Then I insert data from the test data sheet, flow, and pressure, and then I adjust the efficiency until I end up with a roughly similar power consumption. This gives me a performance indicator, key performance indicator 1 and 2, which is the same indicator, just explained in two different ways. I have similar data for the VSD variant and calculate this in the same way. As can be seen, the efficiency of this compressor is slightly lower. This is to be expected, but at the same time, it indicates that one should try to avoid having a VSD compressor working as a full load compressor. A VSD compressor should be the first compressor in and the last out of the configuration. Okay, let's look at key performance indicator 1. And here you see, even with a new and modern compressor, you have to pay minimum approximately 6.5 kilowatt per meter cube per minute if you want to operate with a pressure of 9.5 bar. Now we know the price for each meter cube per minute we want. Let's try to put this number into an imaginary example. Imagine you have these 3 compressors, but on average only 2 are in operation. It provides a total capacity of roughly 83 meter cube per minute, but an average daily consumption of around 56 meter cube per minute. Also imagine that the leakage loss is 30% of the daily average consumption, which is not unusual, and that this can be reduced to 10%, which is not difficult. The operating time of the compressor system is here 8,000 hours per year. Now we could ask, what is the saving potential? What is the payback time? And what is the CO2 reduction? Before we go and continue to some results from this little example, I will mention that there may be a phenomenon that we call control gap in this compressor configuration. But that is an area we will cover in a later webinar. So with this, a small cliffhanger. What I can say now is when the blue line is above the orange, you are in a control gap area. And a control gap area is an area where 2 compressors, they will fight to be the trim compressor. But more about that in a later webinar. Then back to results. Allow me to highlight some of the results, such as annual electricity saving, financial saving, energy only, financial saving, all included. And then something I find extremely interesting. If we project the CO2 factor for Europe by 2030 and you probably remember this number from one of the first slides in my presentation, there will still be a saving of more than 57,000 kilograms of CO2. I repeat, 57 tons of CO2 concerning this little imaginary project. And I don't think the problem of climate change will be less by that time. So why not just start right away? Enersize has the solution. Payback, don't worry, less than a year, probably closer to half a year. I will present here the solution from Enersize. It consists of the Enersize software as a service suite for energy optimization of industrial compressed air following Q+ Leaks, which is software support for leakage detection and repair management. Q+ Money, software support for continuous monitoring. Q+ Zone, which is software for zone-based monitoring. And then finally, Q+ Enterprise, software support for enterprise-wide visualization and real-time optimization. But Q+ X-ray is the foundation of what we offer. This is what forms the basis of the entire further course. This is where we uncover the possibilities and potential for savings in your compressed air system. Q+ X-ray is an analysis of your compressed air system, which can provide answers to the following. Do you use the compressors in the most efficient way? Does the air meet, for example, the humidity requirements? Do you use the compressors at the lowest possible pressure? Do you run the compressors with optimum coordination? Do you have any critical pressure drops in the system? Do you know how much air is consumed by leaks? And do you know the cost of your compressed air? At Enersize, we do not guess. We base our analysis on facts, and for this, we use equipment, loggers. The pictures show a small selection of our Enersize portable data logging equipment for compressed air systems, an advanced and application-specific Q+ X-ray system product consisting of precision and high-frequency data loggers. The data that can be logged includes pressure, temperature, dew point, and flow rate, and these data can be logged anywhere in the system. In addition, current and voltage loggers enable current, voltage, power factor, and the true power of each air compressor to be accurately logged. The base station communicates via the internet using our cloud platform, and the loggers communicate with the base station locally using Bluetooth. This in connection with transferring Q+ X-ray information to the loggers and then uploading measured data from the loggers to the base station. The loggers are battery powered and the data sampling rate is 1 second. The loggers typically need to be placed in a facility for 14 days. This in order to capture as many different operating situations as possible, including how the compressed air system responds to these different situations. Here you see an example with a compressed air system with 3 compressors and different production lines, including a proposal for the type and the number of loggers that should be used in connection with a Q+ X-ray analysis. 3 amp loggers are put up inside the compressor cabinet or in the switchboard. A dew point logger in a dry area after the air treatment, dryers and filters. 1 to 2 pressure loggers are put up close to the compressor station before and after treatment of air if possible. This measurement will be called the system pressure. In case of 2 or more compressed air stations, pressure loggers will be installed in each station. And about pressure loggers on the demand side. Pressure loggers must be put up where you have a reason to believe that the company has problems with pressure drops due to, for example, high volume intermittent demand events or the most far away location from the compressors. Pressure loggers before and after each regulator to different production lines. This in case you want to investigate specific equipment or production lines. The location of pressure loggers should be based on experience and an interview with relevant staff of the company. With these words, I will say thank you very much for your attention. And I will now hand the microphone back to Anders Liv. Thank you very much.
Thank you, Bo. Thank you very much. I now see much more clear why there is such an opportunity to save money and carbon footprint when we do energy optimization of compressed air. Thank you, Bo. So let's look at how Enersize is developing our products to support all of this. I will hand over to Anders Sjögren again, but we will also meet Rebecca, who is in the lead of the work at our research and development. Anders, please introduce us to what is cooking in the research and development area.
With pleasure, Anders. Well, I don't think you have missed the news by the Intergovernmental Panel on Climate Change, IPCC, when they in August released one of the 3 parts of the 6th assessment report on climate change. This report tells us that no matter what we do, the temperature will continue to increase for another 30 years. If we want to limit global warming to 2 degrees centigrade in the 22nd century, we have to do deep reductions in carbon dioxide and other greenhouse gas emissions. I have a deep trust for science, and this IPCC report is the result of work by 234 independent scientists from all over the world, drawing on the best knowledge we have as a human race, and doing their utmost to provide objective data and interpretations. I think it's worth listening to what they have to say. Enersize is listed on Nasdaq First North in Stockholm, and we are backed by investors that rely on reports such as the one from the IPCC. To the best of our understanding, waste of energy must not continue. An investment in Enersize, whether you are a customer that buys a subscription or you are an investor that invests in shares, it is an investment in the future of our planet. Because Enersize is part of the change that we are experiencing in society today, with an industry that starts to prioritize sustainability. Just as the climate is difficult with many aspects to consider, energy optimization of compressed air system is complex, and that is why there has been no standardized solution available. Enersize has identified its core and built compressed air services through 2 mergers. And we are now fully focused on standardizing energy optimization of industrial compressed air based on input from sensors in compressed air system. And we use software because software can do analysis on big data faster and more repeatable than any human can do. And therefore also we have grown our software team a lot in the last few months. At the core of Enersize lies our investment themes that guide us to build services that are extraordinarily easy to get started with and use when you are in the industry. Our products align in an end-to-end solution for energy optimization of industrial compressed air. And we use open standards because they always prefer to simplify integration of our services into your OT and IT environments. User experience is very important when making complex services easy to use. And the vision with compressed air services is to automate as much as possible of the manual work, providing KPIs and decision support in the way that you want it. We are growing internationally through partners, so we prioritize ease of localization. Technology has advanced now to a point where it is possible for a core team, such as in Enersize, to build a scalable, standardized solution with great value to people all over the world, unlocking great energy saving potentials in industrial compressed air. At Enersize, we have built a cross-disciplinary research and development team with experts on compressed air, machine learning, mathematical modeling, and software development. Even if we serve a customer base in industry which is male-dominated, our R&D team consists of 80% women doing their utmost to provide our customers with the best data available on compressed air to make a real difference and lower the energy consumption and carbon footprint. We're part of the good guys, as Anders put it. So I would like to present the team leader for the software team in Enersize, Rebecca Rubio Lopez. Rebecca changed career a few years ago and went into software and joined Enersize in January 2021. You will talk about what the research and development organization is working on right now, won't you, Rebecca?
Yes, thanks, Anders, and hello, everybody. Yes, as you said, we work to make advanced technology simple and available to customers all around the world. Right now, one of the most important projects that we are building in the R&D team is a new portal for customers and partners. The idea is to use this portal to collect key facts about the customer compressor system, and with that information later on, we will be able to monitor and upgrade their compressor system. This portal stores advanced information about compressor system tools, like, for example, the compressor model characteristics, dryers, temperature conditions, etc. And it will guide and help the customer to complete their information, even if they are not a compressor experts. To achieve that, the R&D team is developing a system that will reuse the data that is stored in our database to validate the information that the customer is filling. We are also working with our educational team to provide support information like videos and material that is going to be available in the collection process. So the user will have always suggestions and support about how to fill in the correct information. We think that the information collection is really important because it's our first step in our sales models. The X-ray that brings insight into an unknown compressor system, even in a matter of a few weeks. The portal will eventually contain all our services from Enersize Academy, the compressed air services. And apart from the new portal, in the R&D team, we are laying the architectural foundation for compressed air services generation 2. This means that we are upgrading our products with advanced technology regarding, for example, the collection and the transmission of data using MQTT protocol. And I'm really looking forward to show you more about this, but this will be in the following webinars. So for now, I just want to finish that we love input from our users. We have a board of product managers that prioritize user requests and another task to create our roadmap in the R&D team. And more feedback from you, who are our customers, is very helpful to create a better user experience. As part of this, we are launching the Collaboration Lab. It's a set of initiatives to work closer to the customer and our target market. Anders will now give you a bit more detail on this, so I will stop here. Thank you.
Great work, Rebecca. Well, to measure is to know, said Lord Kelvin in the 19th century, and that is a statement we stand behind at Enersize. By measuring, we can gather facts, create benchmarks and standards for industrial use of compressed air, and compare sites anywhere in the world. And as Rebecca said, we want to work close with our customers when we develop our services. You know your situation best, and it is our work to figure out how to provide suitable services. Because of this, we also started the Enersize Advisory Council with international experts and representatives from industry to guide the future development of the company. Additionally, We invite customers to become early adopters and help us evaluate new features and functionality. And right now we are running pilot tests with a new IoT cloud gateway, aiming to bring it into full use next year with the launch of Generation 2 of compressed air services. If you are interested in joining as an early adopter, just let us know and we will give you a really good offer, an offer you can't refuse. So before I finish this part of the webinar, let me bring you a few highlights from Generation 2 of compressed air services. We are working to launch it during the next year, and we are working also on an improved user experience with a new portal for information collection that Rebecca was talking about. There will be an improved alignment between the different services we have in our Enersize compressed air services platform. We are working on enabling new algorithms based on big data and machine learning. And there is a new modern IoT solution coming up that easily bridges from OT to IT using open standards. And we are looking for early adopters. So now, Anders, I know you have some upcoming Enersize activities for us. Please let us know more.
Thank you very much for this update, Anders. And Rebecca, a special thanks to you. It is very exciting to see how much that is actually being built as we speak, and also to understand how important Enersize see the engagement from customers and partners in the development work. I will now look at some of the tools available and activities that are coming up, looking forward, all aiming to increase an interest for energy optimization of compressed air. The first area I want to highlight is the Enersize web, energize.com. This is a great resource for learning, for reading about customer case studies and how they experienced the energy savings, and for learning in general more about compressed air. If you do go into the site, one of my favorite areas is what is called the Enersize Bootcamp. This is a place where you can learn a lot about compressed air, but also find fun facts that might surprise you. When you feel ready, there's also a quiz, so you can test your skills and insights that you have been building up. So please go and check the web. It's a great resource for learning. Anders was talking about the advisory council, and we initiated that in May, and in end of October we are running our first physical advisory council meeting at the headquarters in Lund in Sweden, gathering key customers, thought leaders and experts from different parts of the world, and I'm really looking forward to the outcome of this. The council will work with the evolution and driving more efficient tools and solutions for energy optimization of compressed air. And of course, the council will be a very important sounding board to Enersize in the product as well as the business development of Enersize. I also want to talk a little bit about our ambitions with the webinars that you have just been through. In upcoming Insight webinars, we are aiming to have customers sharing their experience to give good examples from the field. We also have plans to engage some of the world's leading minds in this area of compressed air, such as our bloggers Ron Marshall from Canada and Elvira Rakova from Italy, two true experts that are part of the wonderful network of Mr. Bokuro. We will also take the opportunity to look into other related development. I have two examples here that is coming into future webinars. One is SciPag, where Luca Pagni and his team are developing intelligent cylinders. Anders said in his presentation that the cylinders are the muscles of the production. And yes, they are the muscles of production, but they tend to be quite stupid, but strong. If you bring intelligence into a cylinder and you do that on a broader basis, you suddenly have a living creature in the production environment. Because if the cylinders are able to speak and tell you when they are leaking, when they are starting to get weak, you can actually predict and do maintenance before it impacts the production in a negative way. And of course, there is a huge savings potential in the energy going bust. Another really cool example is the Squarehead Technology, a Norwegian company that is specializing in super sensitive microphones. So you can call them building super hearing. It's almost like superhero things. And they have an ambition to automate leakage survey. So instead of going around the plant with an ultrasonic instrument, you would have something permanently installed that is looking for the deviation in acoustic fingerprint and being able to point out where a leak is coming up. It's hard to imagine, but it's very interesting. So there is a lot of interesting topics coming up. And if you have an interest in topics like this, you should sign up for the newsletter if you have not already done so. The next newsletter is coming out the 12th of October. And for your information, all already published newsletters are available on the web. So it's really a source for knowledge. Well, finally, I want to highlight that the Insight webinars is part of a larger initiative that we call the Collaboration Lab. Different initiatives to secure that we work close to customers and close to the industry we're serving. We have already discussed the Industry Advisory Council, and you have just experienced our first Insight webinar. And during Q4, we are aiming to initiate a customer community that we call Share Your Story Community. As the area of energy optimization of compressed air is not an area where anyone needs to compete, we can all share our stories and help each other to drive energy optimization and to lower the carbon footprint. So please make sure you are joining when the day is coming. With this, I want to thank you. Thank you all for taking part in this webinar. The next webinar is planned for December 21st and 22nd, so you can see it as an early Christmas gift. But until then, stay safe. Thank you for listening and have a wonderful life. Bye.